Hello friends and hello student. My name is Ashok Sijal. In this session we learn the insert one element in one dimensional array at runtime in C language. So yes, here I share my laptop screen and fix the position so you can watch better my video lecture. And here Turbo C++, I double click and take some process, and now yes is open Alterac file menu, taking a new file, and our goal, write a program to insert an element into 1D array at runtime, specify index. Yes, so you can specify or specify your index. So that is a runtime. Yes, we can runtime insert new element to our existing one dimensional array. So yes, that is new definition for you, I think. So five, like our first size five array, and now new, that is our six element size. So we can increase the size one dimensional array at runtime. So let us take how it possible. So that is insert, update, delete, and search and remove. That all are operation of a duplicate element remove. Delete is also different, and remove is we can duplicate element also delete. So that remove operation known as, so that is operation in database side. That is some operation we can apply to our one dimensional array. So that is very interesting for your knowledge. So let us start. And here our main function, and first here I declare the static size of 1D array, and then I index in size, and then for position new we can, or we can say that index, yes, not position. So idx index, so that is short, and then for new element a. So all are well. So let us take how it possible. So first we can scan and print 1D array. So here we can say that enter 1D array size. So after we can also use malloc and free function dynamic 1D array. So that is we can use that n size of array. And then here first we can give the message and then taking for loop. So enter 1D array elements, and here slash n, and then for loop we have to take. So I equal to 0 because index start with 0, and n I plus plus. So and we can scan with index and print with index. So runtime we can scan. So yes, here x percentage d, and then we can say that I, and then scanf function, and then percentage d and m x of I. So that scanning is complete, and then I copy the scan part and copy and paste to our print part. So input and output, that is we have to first complete. Any definition you can follow the rules. Just what is a rules? So just any video lecture I can say that divide your definition in three parts. So process, input, then process, and then your output. So here we can complete first output, input and output. Process is a logic. So after you can some paperwork and then apply to your logic. So here we can remove this enter not 1D array element R, and here I remove the scanf function, and we can print with index. So here percentage d and slash and provide to here, and remove the brace. Only one statement there is optional to opening closing brace of any loop or any decision statement. So yes, I first save this file. So array 1D and insert operation ins.c insert. So that file is saved, and yes, first we can scan. So and print. So compile. Yes, yes. Here I for your reference. So that is open. So input, yes, our input ready, and output ready. Now process is remaining, so now there is no any error. So exe file is generated and we can take only 3 element testing. So yes, that perfectly scan with index and print with index. So that is first part we have to achieve perfectly. So that is very simple, I think you have to know. And here that is first our input, yes, and here our output. Now in between there is a process, so input, process and output. So now we can first take the element, enter, insert element. Yes, first we can insert element, take from user. So that is a new element, yes, and we can scan from user A. And then we can take that index, which index you have to insert at runtime. So enter index of insert element, that type of message, and scan also uh, IDX. IDX means index, so that is a short IDX, index. And then we can now start our logic and then for loop. So I assign to n, yes, and I greater than index, yes, not position, index. You can also insert as a position, and then I minus minus. So we can, what to do here, shifting our elements. So x of I to x of minus I. So all elements shifting one by one. And after that, here I is greater than index. So whichever our index is taking, that is a loop is terminate and we can insert to our element. So yes, let us take. So here I give the IDX and then our new element A. So that is insert. And our one-dimensional array size is also increased. So n plus plus, that is a increment operator. So that is a perfectly, so that is our logic. Yes, so very simple. So that is logic. Okay, so now I compile. Yes, there is no any error. And let us take. So here we can give 5 size array. 1, 2, 3, 4, 5. And new element I give the 9. And index is 3. So index, enter index of insert element, yes, or new element. You can also word use new element. So look, that is exactly that third index, that 9 element insert. So how it's possible? Very simple, that our logic. So yes, let us take watch window. So here that we can directly control F8. So here we can start because that is all our scanning part. And then you have to know very well, we can, yes, I first all close window and then open to work because that message and all are. So here our insert file is there. So that is here. And now open here and we can provide first watch. Yes, so all that is already. And then minimize size. So now alter W and taking the watch window. Yes, here. And then output window. So what we have to take, and then you can take x of I and then x of I minus 1. So that is a shifting and n and that IDX index and then new element A. So that type all we can take our element. And now I press F7. So first I control F9 so we can scan and take in index and that our new element. So I give again same 5 and then 1, 2, 3, 4, 5 and new element is a 9 and then index is 3 new element. So let us take how it's possible. So here look that our initially n size is 5 and then I is taking to 5 element. Yes, so here I is a first I assign to n and then that is shifting means I minus 1. So there are two 5 one time in the our array. So let us take now I assign to n is a 5. So yes, look that our that is a 5 element and here also minus, that is a taking or copy, that is a here I minus 1. So I is 5 and minus 1 is a taking the 4. So that element is 5, but that is a copy in left. So that is a copy here. I is a now 5. 5 is a or 6 element means x of 5. So x of 5 that copy is a 5 and that is taking remove. Now that copy into this 4 is taking to here again that copy. So let us check. So I is a now minus minus. So I initially that is a 5 and now minus minus. So let us check. I also take as a I variable. So yes, new element is not required. We have to know very well. So I remove and place the I. So you can look here. I is 4 now. First 5 is there. Now I 4 and minus 1. So 3 store 4. So 4 taking to the 4 index means that is a shifting here. So I press F7. So yes, you have to know here that I is a 3 now, but before that 4 and that element is also that copy. And then our IDX is taking same, yes, that is a IDX 3 and I is also 3 index, so not equal to, so that our desired that condition is false. I press F7. So look here that A is copy now and new element that is copy in the IDX. So that is a 9. Yes. And then that one DRA print one by one. So that we can shifting one by one. So directly I assign to n. So n is a 5, but 5 index is not our array because we can enter 5, but only 4 index come into picture. So n plus plus now is 5 and that is 6 elements. So you can look now our third index taking 9 element and 5 n is 5, but that is terminate because that we can not equal to. So that is a 6 0 to 5. So that is 6 element. So initially we shifting our element and at a time one time that is a one element in the two place. So first here is a 5 and I minus 1, 4 index also 5 and 5 index also 5 and then 4 taking to I minus 1. So that is shifting and our desired index reaching that loop terminate and our new element insert that element and we can n plus plus. So runtime we can increase our array size and runtime we can insert or also new element. So that is a logic. So very simple. And I remove this control F8. So that in watch window. And now we can take dynamic. Yes. So here what to do? So you have to know. Here we can just pointer and here we can I also change the pointer P. Okay, and then we can assign the memory allocation to here p equal to type casting integer, yes, and then malloc function we can use and that is we can n multiply size of integer int. So that is a dynamic array, yes, and here we can change x to p or pointer. So I give the p and so here also I give the p and then n or here also I taking the p. You can also take x, no problem. And now here also print the p and then free, just free function. So we can pointer, so p pointer, so we can take the p as a array. So yes, let us take that is a dynamic array now. So I can apply in both insert one element. So there is no any error. So very simple. That is a typecasting and that is a malloc function return the void pointer. So we can typecasting and n multiplies size of integer data type. And if here is calloc, so you can operator comma and give the here calloc. So that is simple. So first we can take malloc and multiplication. So only one argument in calloc and calloc there are two arguments. So runtime we can size that is a dynamic now totally. First we can fix the 20 size, but now is totally dynamic and I give the second position and 8 element we can change our. So look that is yes we can plus plus. So that is a yes here remaining. So and yes and here our element. So and greater yes that all are well. So where is problem is there? This what happened. So 8 index. Okay, so element is new. Okay, so I insert the index is a wrong. Yes, yes, yes. Here is problem. So element first and then index. So yes, that is I let us run again. So I give 5 and give the same element. No any problem because here new element. So first I give the 8 and now index. Yes. So I first previously I give the wrong order. So yes, that perfectly. So that is second index x of 2 or yes, message we can also change. Now our new array name is a not x but that is p, or you can also take x, no problem. So yes, here us now convert in dynamic array. So malloc and free function, and yes, now also assign the calloc. I just comma the two argument and calloc. So again run, and now I give the different element means size is 5, but randomly element, so not sequence. So you can also understand we cannot apply element as sequence. Now insert the element. Yes, insert first element. So I give the any element like 9 and then position. So we can 2 and then let us take I give the uh, 4. So that is a last 4. Yes, so now 6 but that index is 4. 9 element insert exactly 4 index. So that perfectly all are well. Yes, so complete our session. So runtime we can specify the index, get new element at runtime. So that is a insert operation we can perform in one dimensional array. So all are well. Very simple logic here, and also we can take watch window. So one by one element is shifting in the last index because n I assign to n. So that index is not in the array because 5 we have to enter, but 4 index, but n is 5. So 5 index shifting that first 4 index element, and then 3 index shifting the 4 index. So one by one all element is shifting, and our desired index is a blank, means that copy at a time one element in two place. So we can remove one element, means place remove and then assign to our new element. So new element already we can take in some place, means previously some shifting element, and then we can desire achieve to our desired position to reach to that place using this for loop. So yes, write this program to your C not C book if you prepare. Very interesting and very simple logic I develop for you. So I close this file, Alt F3, and also watch output and quit. So subscribe my channel Ashok Sijalaikarni, press the bell icon to never miss any update. Thanks for your watching, supporting and sharing my video lecture, and Hare Krishna.